Hello everyone, Ismail is here. Today we're going to learn about 1.4 Extrema and average rates of a change. Okay, what you are expecting to learn in this lesson is written here, which is we need to determine intervals of the function at what is increasing, constant or decreasing, and determine maximum, minimum of the function. And also we are going to learn the average rate of a change. Okay, now let's start with the lesson about first thing about increasing and decreasing part. So increasing and decreasing part is easy parts. As you can see, we have here four, or let's say three different way to present the increasing, decreasing, and constant. Okay, so as you can see here, let me just give you a small example here on the side. So if I tell you that if I have this line is going up like this, so this one is what? This one is called increasing. Okay, if I give you this line here, it's going down like that. Okay, so I will say also this one is increasing, not decreasing. Okay, why? Now, why this one is increasing and this one is also increasing? Because we know that the increasing always, when we read the function, when we read the interval, always we start from left to right. Okay, so from left to right, so you have to first look to the point on the left, then move with your function. If the function is increasing, so that means this point is low, okay, and this point is higher, so that means this line is increasing. Even if the arrows goes down, so if the arrows goes down, we read from left to the right. So we start from the arrow, so from arrow then we go up. So as you can see, the arrow, it was down, and the right side it was up, so that's increasing. Okay, so always we have this line is increasing, this line increasing from down to up, down to up. So what's the difference between all of these line? The difference between them is the slope. Okay, so as you can see, this line here has less than slope than this line here, so this one has more slope than the first one. Okay, now, so we call this one increasing. Now, how about the decreasing? The decreasing is start from left to the right, but the point should be from up, which is decreasing, goes down, okay, like this. So if I tell you that if the line is going like this, okay, so as you can see, if you say that this is increasing, okay, so I think you need to rethink about that. So this is not increasing, this is decreasing, because always we start reading the graph from left to the right. So from left it was up and goes to the right, then down. So every time, as you can see, from up the higher value to the lowest value, so this one is decreasing. So this one is decreasing, 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 even these lines. So what's the difference between these lines as decreasing? Okay, is only also the slope. So this has low slope, this one has high slope. Okay, now the last one is the constant. What does the constant mean? The constant means like not a function or just numbers. Example, if I say y equal 3, so 3 just a number. Numbers means constant. So when you need to graph number 3, so number 3 is a constant, which is just a straight horizontal line. So this straight horizontal line is a constant. We call this one as constant. Okay, now what's the value from the constant when we read it from left to right? So as you can see from the left, and if we move to the right, we are on the same level. So that's why we call it constant. Okay, now let's have examples to check what is the behavior. Use the graph, if we read the question, use the graph of each function to estimate intervals to the nearest 0.5 unit on which the function is increasing, decreasing, or constant. Okay, so we need to find what's the interval is increasing, which one is decreasing, and the constant. Support numerically. We're not going to support it numerically, because we say that if it's the value is smaller, then the other value is bigger or greater, so that's mean increasing. If the value was bigger, then the value becomes smaller, so this one is decreasing. Okay, now if you look to this function, always when we start reading from left, okay, to right, don't forget. Now if you look to the graph, so from left, so the left it was up, then if we move to the function is still decreasing, decreasing, decreasing. So from the beginning to the end, okay, so the function is decreasing. Okay, and as you can see here, it was in the left, it's an arrow arrow means, okay, infinite, but infinite to what side? To the left. So this one negative infinity. Even it's going up, I know it's going up, but up to where? To the left. So that's mean we focusing the interval only on the x-axis. This is negative, this one is positive. Okay, so this line is going to the negative infinite. Okay, so from negative infinite to positive infinite, even if this one going down but still going to the right, so that's mean is positive infinite. Okay, so this one is the interval. So from negative infinite to positive infinite is decreasing. So what we call, because the function from the beginning to the end, so we call this function decreasing function. Okay, decreasing function because all the function is decreasing. If the function has different values, like this example here, x cubed minus 3x. Now let's take the decreasing part. So the decreasing always from the highest to the lowest, or you just follow the function, start from left to the right. So now if I need to follow the function from here, so this one is an arrow, it's going to the left forever, right? So from negative infinity, then so I will start from negative infinity to where? So this one is increasing until we reach this point. So as you can see this point here, then after that goes down. So what is this point on the x-axis? This one is negative 1. So from negative infinity to negative 1 is increasing. Okay, so this one is increasing. Then if we continue moving on the function from this point here, from negative 1, if we go with the function, it's going down. So this point to this point, okay, on the x-axis, so this one also is negative 1. So now between sorry, not negative 1, so positive 1, sorry. Okay, so this one should be positive 1. So now between negative 1, the interval, and 1, okay, negative 1 and 1, the function is what? Is decreasing. Okay, because from the higher value to the lowest value. Then the next one, if we continue from 1 and we go to this line, it's going forever to the infinite. So that's mean from infinite, from 1 to positive infinite, also this one is increasing. So we have two intervals increasing and one interval here is decreasing. Okay, so we can't say this is increasing function and we can't say this decreasing function, because this function has both, have increasing and have decreasing. So I can't just say this function is increasing or decreasing. So this one has both increasing and decreasing. Okay, now let's have a look on the critical, extrema, maximum, point of reflection, and minimum. Okay, now before we start doing this, let's read what is the critical point means. Critical point of a function are those points at which a line drawn tangent to the curve is horizontal or vertical. So as you can see in this graph, so look to this function in the blue color. Okay, so this function, this one here, then at this point here it's turns down. Okay, so this point here, if I draw a straight line or straight tangent on that point, so this point here is called a critical point. Why? Because when you have a point, or let's say you have a graph, okay, and I draw a straight line, so this straight line is intersecting with my graph with only this point here. So because it's intersecting with only one point, so we call this point a critical point. Okay, now then we have the extrema. Extrema are a critical point at which the function changes its increasing or decreasing behavior. Okay, now if I give you this example here, look to this example. Let's say I have this is y and this is x. Okay, and let's say the function goes down, up, down, then stops here. Okay, now the maximum and the minimum. So as you can see here, we have two type of maximum. We have an absolute, okay, maximum, and we have a relative, okay, maximum. Okay, what's the difference between absolute value maximum and relative maximum? Absolute maximum means it's the highest value within all the interval of the function. So if you look to this function, which one is the absolute maximum, or how many maximum do we have? I have maximum here, I have maximum here, and I have maximum here. But is which one of these 3 points I call it absolute maximum? Absolute maximum is the highest point. Which one is the highest point? It's this one here. So this point here is the absolute maximum. Okay, now the other one is the minimum. Okay, the minimum also we have absolute minimum, okay, and relative, okay, relative minimum. Okay, sorry, relative minimum. So what is the absolute maximum and the absolute relative minimum? Okay, or absolute minimum, absolute relative minimum is when I look to this function here again. If I look to the same function, or I draw another one, so which one of these, okay, will be the absolute minimum? So as you can see, first identify all the minimum. So this point here is a minimum, this point here is a minimum, this one here is a minimum, okay, and this one here is a minimum. So as you can see, I have 4 points minimum, but which one is absolute minimum? Absolute minimum means the lowest value in your function. So this one here is called absolute minimum. Okay, what about the other 3 points, the minimum? So we call all of these points are relative, okay, minimum. So when I have minimum points more than 1, okay, and they are not the absolute, so we call them relative minimum. And the same thing happened to the maximum. So if you look here, so I have here maximum, I have here maximum, I have here maximum. So which one is the absolute? The first one here is the absolute maximum, okay. And what about these 2 points? So we call them relative, okay, relative maximum. Okay, I hope you understand this. Okay, now then we have the point of reflection. Point of reflection is similar as the critical point, where is the function, okay, has a critical point, or where is the function changes from increasing to decreasing or from decreasing to increasing. So this graph here represent what I just explained above, okay. So the first graph here shows that the maximum value. So I have 2 maximum. This is the maximum and this one here is the maximum. But which one is the absolute? This one is the absolute maximum. This one should be the relative, okay, relative maximum, okay. Same thing here. If I have look to these 2 points, this is an absolute minimum, okay, and this one here is a relative minimum. Okay, now if I ask you about now this graph here, do I have a minimum? So if you say, if you tell me that yes teacher, this is the minimum, yes, so I will tell you this is the minimum. But is this minimum absolute minimum or relative minimum? Okay, look to the function from the beginning, from left to the right. From left it's going down forever, and from the right also it's going down forever. So as you can see, the function, it will never end, okay, while it's going down. So this one will be an absolute minimum? No, it will not be absolute minimum, because the function has no end point, no minimum value. So we call this one only, okay, relative, okay, relative minimum. So when the function goes down forever, okay, so we call this one, we call any minimum point as a relative. There will be, okay, so you have to write no minimum, or let's say not no minimum, we just say no absolute minimum when I don't have absolute. Same thing happened with the maximum. Look to this function. This point here, okay, is represent the maximum, right? But is it absolute or relative? Okay, if you look to the function from left, it's going up forever, and also it's going right forever. So of course the function does not have absolute maximum, because the function will go up forever. So we call this point relative, okay, maximum. So we can't just say no absolute maximum. Okay, I hope you understand this. If you have anything, please tell me. Look to this example. Okay, the question said estimate, okay, estimate and classify extrema for the graph of x. Support answer numerically. Okay, we are not focusing on supporting numerically, because numerically means you will have to pick some points and put them in the function, and this is like something you substituting values, and we are not going to substitute values. Now look to the function. First, how many maximum, how many minimum do we have? So any change, any critical point, so this is the first critical point, this one here in the green one is the other critical point. So the blue one here represent maximum or minimum? It's represent maximum. Why represent maximum? Because start from down, then which is it was increasing, then decreasing. Okay, how about the green one? The green one, it was decreasing, then increasing. So this one is minimum. Okay, so the minimum is always the value, okay, the value on the left will be higher than the value on the right. Okay, so the value, or sorry, not the higher, the value on the right will be greater than the value on the left, okay, according to the x-axis. Means if I pick this point on the x, so this one here, it will be let's say this is half, and this one it will be 2. So this is the difference that you can see here. Okay, now if we plug in the values in the function, you will see one of them is greater, one of them is less than. Now, if the most important question is, are those 2 points, the maximum one and the minimum one, are absolute or relative? Okay, so both of them will be a relative. Okay, like maximum, it will be relative maximum, it will not be absolute maximum. Why? Because if you complete the function will go up forever, so that's why it's relative, okay, maximum. Same thing happened with the minimum. Also the minimum will be relative minimum. Why it's relative minimum? Because it will go down forever, the function. So there is no absolute maximum and there is no absolute minimum, so we call it, there is no absolute extrema. Extrema is just a word. Okay, what's the meaning of extrema? Extrema is a word that represents maximum and minimum. So if I'm mentioning maximum and minimum together, so I'm just saying extrema. No absolute extrema means no absolute maximum and no absolute minimum. Okay, now this is a practice questions. Try to practice on this question and first please read the question before you start solving. Read it carefully, then look what the question asks you. Is it asking for increasing, decreasing, or asking for the lowest, maximum and minimum, which is the extreme part? Now the second part of the lesson, which is the easy part, which is average rate of a change. Average rate of a change is a lesson that most of the students they study to find the slope or to find the change between two different values. Okay, so example, you studied before in the class how we can find the slope. The slope is y2 minus y1, okay, over x2 minus x1. But now this formula, it was for kids, it was for children. So this is why we're teaching y2 minus y1, okay, and let's say in grade 6, grade 7, or maybe 8 or 9, okay. But here now you are a pre-calculus student. Pre-calculus student, we have to switch the names of y. You know that. What's the meaning of y? Y means f of x. Okay, so if I change y and I write f of x, it will be similar, but it changed the number. Let's say if I'm talking about y2, so that means I'm saying f of x2, right? If I'm saying y1, so I'm just mentioning f of x1. So the same thing, I will just change the y, I replace them and I write f of x2 minus f of x1, right? So x2 minus x1, means the one should be with the x here, so x1. So instead of writing y2 minus y1, so I'm just writing f of x2 minus f of x1, because you know that y means what? Means f of x, and also means g of x or z of x or whatever, okay, any function, any name of any function, okay. So this is what you can see here. So to find the average of rate of a change between these 2 points, every coordinate has x and y, and we replace y with what? With f of x. So this one should be x1, this is f of x1, and this one here it should be x, this one is y, so x of x2 and f of x2, and we can find our average rate of a change. Okay, now let's do this small easy simple question. First, just give a name. So now find the average rate of a change for this function here on each intervals. Intervals means he's mentioning the x-axis or the domain, okay, so both points represent the x. So let's say now x2, or let's say x1 is equal negative 2, and x2 here is equal negative 1. Now let's find f of x1. Okay, let's find f of x1. How can I find f of x1? x1 is equal what? Okay, negative 2. So let's replace in every x here negative 2. So it will be minus, then negative 2 cube plus 3 times negative 2. Okay, so if you apply this one, you will get the answer is 6. The answer here is equal 6. Now let's find, okay, f of x2. What is x2? x2 is -1. So we are going to replace -1 here. So negative with -1 cube plus 3 times -1. So if I did -1 here, so it will be here +1 minus 3. Okay, so it will be -2. Okay. Now, after I found the both values, let's write the formula. So the formula of the slope or the rate of change is f of x2 minus f of x1. Both of them is over x2 minus x1. So f of x2, we already found it, which is equal, okay, let me write here, which is equal -2. So I have to write -2 minus f of x1. f of x1 is equal 6. So it's -6 over x2, okay, is given here, which is equal -1. So -1 minus x1, which is equal -2. So -2 is the number. So now -2, -6 is equal -8. Then here, -1, negative with negative it become positive. So -1 plus 2 is equal 1. So the answer is equal -8. Okay. Oh, sorry, I have mistake. Sorry. Here the answer is not 6. Oh, I just wrote the answer very quick. Okay, here it's -2. So this one it will be 8, okay, minus 6, which is equal to 2. Sorry, the answer here is 2. So now let's change here this 6. Let's change this 8, sorry. Okay. So f of x1 is equal to, it's not equal 8. So the answer here is equal 2. Now -2 minus 2 is equal -4. So the final answer will be -4. Okay, I hope you understand this. It's a human mistake. It's fine, boys or girls. Now the other one, let's solve the other one. Okay, so 0 means x1 and 1 means x2. So now let's find f of x1. So let's replace 0 in the function. So if I replace 0 in the function will become 0. But let me replace it for you. So as you can see, -0 cube plus 3 times 0 is equal. So this one is equal, this part is equal 0, this part is equal 0. So 0 plus 0 is equal 0. Now let's replace f of x2. So it will be minus 1 cube plus 3 times 1. So 1 cube is 1 with a negative, so -1 plus 3, -1 plus 3 is equal 2. Okay, now let's write the slope. Okay, f of x2 minus f of x1, both of them over x2 minus x1. So f of x2 is equal to minus 0 over x2, which is equal 1 minus 0. Okay, so the answer is equal to 2 over 1. So the slope is equal to. I hope you understand this. Now the last example here, how we can find average rate of a change for some real world question. Let's read the question and to understand it and try to understand it. Always when you have real world problem, don't focus on what's the question asked, or let's say what is a lot of talking. Just focus on the numbers and focus on the last sentence, what the question asks you, what the question needs. It will be easier for you to understand the question. Now, the height of an object that is thrown straight up from a height 4 feet, okay, above ground is given by this formula. So the formula is this one here, okay? And 4 represent the y-intercept. Then, where t is the time in seconds after the object is thrown. Find an intercept average, okay, so we need to find average speed, okay, of the object from 1.25 and 1.75 seconds. So the times t1 and t2 is given, okay, so t1 is equal 1.25, t2 is equal 1.75. So now what you have to do, just apply the formula to find the average rate of a change, okay, h of t2 minus, okay, h of t2 minus h of t1, okay, just replace them in the function. Let's replace them. So the first value is 1.25 1.25 is equal negative 16 times 1.25 square plus 3 times 1.25 plus 4. So the final answer will be, I think, 1.25 square is equal times the 16 plus 3, okay, plus 4. Okay, so the answer is negative 17.25. Okay, so this is the value on this one. Okay, now let's find h of 1.75. So let's replace it in the equation. 1.75 square plus 3, 1.75 plus 4. Okay, so 1.75 is only half more than 1.25. So if I need to replace or simplify this one, so 1.75 square times negative 16, and so it will be plus 3 point. Okay, so the answer is negative 39 point something. Okay, so now wait, but let's check answer, is our answer is correct or no, because as you can see, this one is negative 17, this one is negative 39. Okay, and if we look to the graph, this point here, okay, on the y-axis is not negative 39, and here it's not negative 17. So now if we check our answer, let's check again. So the equation negative 16t, okay, plus 30. Okay, it was a 30. So now I did mistake here. So it's not 3. Okay, it should be 30. So now I have to replace and change number 3 and write it as 30. Okay, so let me erase this. Okay, I'm sorry. Let's redo it again. Okay, and find the values again. Now, so it will be plus 30. 1.25 plus 4, and it will be plus 30, 1.75 plus 4. So the first one here, I think it will become 16.5, okay, and this one here, it will become 7.5. So now this is correct, okay. So these are the values are correct now. Now let's put the values in the equation here, okay. So now it will be the slope or the average rate of a change. It will become 7.5 minus 16.5, the values that I get, over, okay, this one minus y2 minus y1, which is 1.75 minus 1.25. So the answer will be this one, the negative. So it will be negative 8, negative 18. Okay, I hope you understand the question, and apologize for this small mistake. We have to make sure that we are copying the exact and the correct function. Okay, so now try to solve this question by yourself, and if you need any help or any question, please let me know. Okay, have a good day and see you inshallah. Bye bye.